Welcome everyone. Today we shall study a new lesson in science, that is periodic classification of elements, and this is part 1 video of this lesson, and this is for class 10th science 1. Alright, so let's study. Okay, so before starting our lesson, let's recall some information. So first question is, what are the types of a matter? So student, there are different types of a matter. So first of all, matter has mass and takes up space. Okay, something which has mass and takes up space, it called as a matter. And the four main states of matter are solids, liquid, gases and plasma. So student, I know you are familiar with solids, liquid and gases and plasma. We will study in higher standards. Okay. Alright, so next question is, what are the types of elements? Elements are simplest chemical compounds in which all atoms are exactly same. Okay, and in periodic you can observe alongside periodic table in which 118 elements are there. So first element is hydrogen, and last element, that is 118 element, is oganescent. Alright, so these are the different types of elements. So elements are the simplest chemical compound in which all atoms are exactly the same. And the three types of elements are metals, non-metals and metalloids. So metalloids having the properties of both, that is metals as well as non-metals. Alright, third question, what are the smallest particle of matter called? So first of all, what is matter? Something which has mass and takes up space, it's called as a matter. And the simplest smallest particle of matter is called as an atom. Alright, so an atom is the smallest particle of an element having the same chemical property as the bulk element. Alright, and you can observe here alongside diagram of a atom, in which you can observe atom contains nucleus, and inside the nucleus protons and neutrons are present, out of which protons are positively charged and neutrons are negatively charged, and around the nucleus electrons are revolving around the nucleus which in a particular orbit, and electrons are negative electrical charges. So this is all about atom. Alright, now next question, what is the difference between the molecules of elements and compounds? Now let's see. Alright, so the difference between a molecule of a compound and a molecule of an element is that in a molecule of an element, all the atoms are the same. Alright, so in the molecule of element, all the atoms are exactly similar. And for example, in a molecule of a compound, the atoms are different. Okay, we will see examples also. So for example, in a molecule of water, what is a molecular formula of water? It is H2O. Okay, that means there are one atom of oxygen and two atoms of hydrogen. So this is a compound, molecule of a compound. But in a molecule of a oxygen, that is O2, okay, both of the atoms are oxygen. That means in molecule of an element, atoms are identical, similar, but in molecules of compound, atoms are different, like H2O, different atoms are present. So this is oxygen at molecule. Alright, now student, let's start classification of elements. So here in this lesson we have to study about different types of element, that is metals, non-metals and metalloids. We will study different theories related to the elements and periodic table also, and different types of property trends related to the metals, non-metals and metalloids. So let's start. Okay. So student, you have already studied that all the atoms of an element are of only one type. Okay, until now today 118 elements are known to the scientific world, and here it is a periodic table which contain different period, different groups, and total 118 element from hydrogen to oganescent. Okay, 118. And there are different blocks are there, like S block, P block, D block, F block. We will study later in this lesson only. Alright, so this is the last element of our periodic table. And however, around year 1800 only about 30 elements were known. So till now 118 elements are there, but in 1800 year ago there are 30 elements were known. Only 30 elements were known, and more number of elements were discovered in the course of a time, and more information about the properties of these elements was gathered. And to ease the study of such a large number of elements, scientists started studying the pattern, if any, in the vast information about them. So different scientists put forward different theories related to and different discoveries of different elements. Alright, you know that initially elements were classified into the groups of metals and non-metals. So initially many years ago, only elements are classified as only in two groups, that is metals as well as non-metals. Alright, and later on another class of elements called as a metalloid was noticed, and metalloids having the properties of both, that is metals as well as non-metals. So as the knowledge about elements and their properties went on increasing, different scientists started trying out different methods of classification. So there are different scientists who put forward different methods of classification of elements. So out of which first is Dobereiner's Triads, second is Newland's law of octaves, and third Mendeleev's periodic table, and fourth one is modern periodic table. It was discovered by scientist Henry Moseley. Okay, so we will study these four types of methods of classification by different scientists in this lesson only, but today we shall study only about Dobereiner's Triads. Now let's study what is this. Okay, so Dobereiner's Triads stood in the year 1817. A German scientist, Dobereiner, suggested that properties of elements are related to the atomic masses. Okay, so atomic mass is the mass of an atom, and we know in atom there are only protons and neutrons are present. Okay, so sum of protons and neutrons gives us atomic masses of an element. Okay, and Dobereiner made group of 3 elements each. So he made group of only 3 elements each having similar chemical properties and called them triads. So he placed 3 elements which are having the similar chemical properties in one group, and it is called as a triads, and the theory is known as a Dobereiner's Triads. And he arranged the 3 elements having the similar chemical property in a triad in an increasing order of atomic masses. So first he made the group of a 3 element which contains similar chemical property, and according to the increasing order of their atomic masses, and showed that the atomic mass of the middle element, okay, so out of 3, atomic mass of middle element was approximately equal to the mean of the atomic masses of the other 2 elements. So this was Dobereiner's Triads classification, and let's understand this by taking some different examples. So however, all the known elements could not be classified into the Dobereiner's Triads. Okay, now let's understand this theory by taking some different examples. So here one table is given to us in page numbers in textbook page number 16. So different columns are given here. In first column it is given as examples of triads. So here 3 examples of triads are given, out of which first is lithium, sodium and potassium. So this is one triad, and second example is calcium, strontium and barium. This is second triad, and third is chlorine, bromine and iodine. Okay, and what is this theory? The atomic mass of middle element is equal to the mean of atomic masses of the other 2 elements. So in first triad, middle element is sodium, okay, and the 2 elements are lithium and potassium. So lithium atomic mass is given, that is element 1, actual atomic mass of lithium is 6.9, and element 3 is potassium, that is having atomic mass is 39.1. Okay, now atomic mass of sodium, it will be equal to 6.9 plus 39. This will be mean of atomic masses of other 2 elements. That means lithium and sodium divided by 2. So it is 23. Okay, and actual mass and in second example, that is calcium, strontium and barium, the strontium atomic mass will be equal to the mean of other 2 elements, that is calcium plus barium. So calcium atomic mass is 40.1 plus barium atomic mass is 137.3 divided by 2. So we are getting answer as 88.7, and in third triad, that is chlorine, bromine, iodine, bromine atomic mass will be equal to mean of atomic masses of chlorine and iodine. So we are getting answer as 81.2. Okay, so in first example, that is sodium, atomic mass of sodium is exactly equal to the mean of atomic masses of the other two elements, it is 23. Okay, and in second, strontium, atomic mass of strontium is equal to the mean of atomic masses of calcium and in third, atomic mass of bromine is equal to mean of atomic mass of fluorine and iodine. That means this is the actual theory of Dobereiner's triads. Okay, I hope you all have understood. Alright, now here one question is given to us in our textbook. Can you tell? Okay, so here identify Dobereiner's triads from the following groups of elements having similar chemical properties. Alright, so here first example is given as magnesium, calcium and strontium. So student, calcium is a middle element and magnesium and strontium are element 1 and element 3. Okay, so we have to check whether the atomic mass of middle element is equal to mean of atomic masses of other two element or not, and if it is equal, then it will be Dobereiner's triad, and if it is not, then it is not a example of Dobereiner's triads elements. Okay, so first is calcium. We will calculate it for calcium is equals to atomic mass of magnesium plus strontium. So after calculating, we are getting answer as 55.95, and atomic mass of calcium is 40.1. That means this is not an Dobereiner's triads elements. Okay, now second is sulfur, cerium and tellurium. Okay, so middle element is cerium and selenium, and selenium atomic mass is equals to sum of atomic mass of tellurium plus sulfur. Alright, and after calculating, we are getting as answer, we will get answer as 79.8, and actual atomic mass of selenium is 79.0. that means it is exactly, it is similar. So this sulfur, cerium and selenium and tellurium is an Dobereiner triads element. Okay, and next is beryllium, magnesium and calcium. So middle element is magnesium, and magnesium atomic mass will be equal to atomic mass, mean of atomic mass of beryllium plus calcium. So it is, after calculating, we will get answer as 24.5, and actual atomic mass of magnesium is 24.3. that is, this is some exactly similar, and that is why this is also an this also series of an Dobereiner triads element. So student, I hope you all have understood how to calculate the Dobereiner, how to identify given elements as a Dobereiner triads element, and that's it for today's video. I hope you all have understood, and next part of this lesson we will continue in our next session. Thank you.